Hello everyone, this is Aditya, and today we're going to see how to find the distance of a star from Earth. And it is a really interesting topic to be discussed upon because I know many are curious to know how physicists figure out the distance of a star from Earth without even measuring it using a physical equipment, for example, a scale like we use in our daily life, or some measuring tape, or something like that. Then, how do they measure such large distances just using some experimental values and a formula? We will see to it, right? Okay, so in this video we will see it using standard candles, right? You must have heard about it. Will try my best to make you understand the standard candles. And then there's something called a Cepheid variable in this, which is an example of a standard candle. And we will see the reason also of Cepheid candle, and the reason is basically due to the Kappa mechanism. But of course, we will discuss it in a algorithm in a sequential way, right? But before that, please do like and subscribe my channel, and please support this video, and please like this video, and please share this to as many people as you can, because I know this is a very interesting topic and a very curious topic to be learned about. So please share it to everyone, and please support this channel. And now we are going to start with the video. So I have a page in which I have written about the calculations, and also that is why I'm holding this, because it has all the data. So while teaching, I would require it. So basically, what is a standard candle? First of all, let me write its definition. Then I will explain it in simple words. Standard candle, right? Well, of course, it has nothing to do with a candle, right? Okay. So it is a class or group of stellar objects which has known luminosity and whose distance, this distance, can be measured using radiant flux intensity, which we will denote it using F. So basically it is a class, means it is a collection, you can say, of stellar objects which has a known luminosity, and I hope so that you know what is the luminosity and what is radiant flux intensity. This is basically the brightness, if I tell in simple words, okay? And whose distance can be measured using radiant flux intensity, which we will call it using F. And there is a specific, or maybe say it is an example of standard candle, which is called a Cepheid variable. So what is it? It is a star or stars whose radius varies periodically. This causes this example, this causes temperature of the star to change, right? So that the luminosity, I hope you have understood what is a standard candle, right? I think that it is clear, of course, right? And a Cepheid variable is just an example of a standard candle, and of course we are going to solve a numerical based on Cepheid variable only, so you have to be very much attentive at this part, okay? It is the basic to understand this concept, right? And it is very simple, and it is very much fascinating to know how physicists calculate so large distances using such methods, right? we think that it is something really, really scientific. No, it is not. It is very simple calculation, very simple, right? When you will learn it, you will understand it is very much simple, right? Okay. And of course, I am not going to that much depth because, of course, if I will go in that, then you won't understand it because I want that this video can be understood by everyone. So that is why I'm trying to be as simple as I can, right? Of course, some basic terms of physics you should know, right? I can't discuss that. Okay. So that the luminosity also varies periodically. Okay. So the first question which might have come to your brain is that why the radius is varying and that too periodically. Well, it is something due to radius varies, radius varies due to Kappa mechanism. What is it? Now, what is Kappa mechanism? Well, when the helium inside a star, its temperature becomes high, then in that case, if temperature is high, then the star becomes opaque. And of course, there must be some specific conditions for the happening of the Kappa mechanism. It can't happen to every star, right? So, hmm, due to the temperature, due to the high temperature, the star becomes opaque, which decreases the luminosity, right? Which decreases the luminosity, right? And when temperature is less, then in that case the star becomes more transparent, and in that case luminosity increases, right? So this is the fact behind the Kappa mechanism and why it happens, right? And of course it is restricted to the outer layer of the star. Okay, so the radius is increasing due to the outer layer expansion and contraction, right? Okay. And one more thing I need to tell in that, if you want to write, you can say opacity and temperature vary uh, directly. You can say, means if opacity means if temperature increases, it means that opacity will also increase. It means it will become more opaque. And if the temperature decreases, then it becomes more transparent, and the luminosity also increases, right? So this is a basic idea of standard candle and example of it, Cepheid variable. And now we are going to see Cepheid variable in some detail, and then we are going to solve a problem. And of course, then I think that you will be clear with how the distances are measured in space, right? Let me raise this. So now let's see the light curve of a Cepheid variable, right? So how does it look? Well, let me tell you. So this is your time, right? And this is brightness, right? In simple layman term, I will say it as brightness, right? So how it looks somewhat like this, like this. Okay, and notice that this is called time period, right? Basically it is the point when it is transparent, more transparent, and it is the point where it is most opaque, right? So here the brightness is least and here it is max, right? So from max to min, then min to max, so one time period. Okay, so this is how we represent in terms of curve, and of course you can give the values also, and this is called a light curve. Okay, simple. But while making the calculations, you are also given a curve which is called a period luminosity relation. But don't worry about it. In that, we basically compare the luminosity of the given star with respect to our sun, and that is the data which is scientifically available. which you can easily find out anywhere. It is already defined, so no need to worry about that. Okay, and of course we will see that graph when we will discuss that question. Okay, a question in that we will see how we use that graph to determine the distance. Okay, so it's okay, we all found these curve, we all discussed this curve. So what's next? Well, here are some points to be noted, which I'm going to tell. First point: all Cepheids, be it type 1 or 2, of some period, suppose t, they will have same luminosity, suppose L, right? So L can be estimated, and of course this brightness from Earth. Okay, from Earth, L can be estimated from the period of the variation of brightness. Okay, so in all time period the luminosity is remaining the same, so we can determine the value of L from the period of variation of brightness, right? From this. Okay, and to find distance, to find distance uh, with L, I mean using L, we use the formula L by 4 pi. This is radiant flux intensity. This is the luminosity. You know this, I already wrote. And this is a distance between Earth and Sun. Sorry, Earth and star. Right? So this is the process that we are going to use while calculating the distance of a star. So F we determine using some gadgets or equipments, of course, whatever. You can use camera also, some other equipments which you will find in lab or somewhere. Okay, so having said all this, let's discuss a question now to understand everything in a better way, and we will see period luminosity graph also. So now we have the question that a type 1 Cepheid variable star in Andromeda galaxy. What is the Andromeda galaxy? You all know, right? It is the galactic neighbor of Milky Way. That is our galaxy. Okay. Have a period of time 30 days. The observed radiant flux intensity of the star is 5.4 into 10 to the power minus 16 watt per meter square, and radiant flux intensity of the sun at Earth is 1.37 into 10 to the power 3 watt per meter square. The average distance between Earth and Sun is 1.50 into 10 to the power 11 meter, and use graph to solve. Well, of course, I will display the graph right now so that you can solve the problem. So what does this graph tell? Let me tell. So the graph looks somewhat like this. This is your period or time or days, whatever you want to say. And this is L by Ls, right? Where L is the luminosity of the star and Ls is the luminosity of the sun, right? Okay. And the graph goes like this, or maybe somewhat like this, and maybe in the type 2 it goes like this. So this is type 2, this is type 1, and there are many graphs which you can understand, okay, depending on the time period and all. Okay, so in the given graph for 30 time period, you have this Let me make it a, yeah. And corresponding to this point, you have over here 10 to the power 4, right? And it is a data which is available in the labs. Okay, it is very much easily available. It is already calculated, so you don't need to worry about it. Okay, so we have L by Ls is equal to 10 to the power 4, right? For time period 30, right? Okay, so now it is very easy to calculate. I hope that you understood the graph now, that what does it mean. So now let me remove that graph and I will solve the question over there. Okay, so we know that f is equal to L by 4 pi d square, right? Okay, which means that f d square by L is equal to 1 upon 4 pi, which is a constant, which means that f d square by L with respect to sun is equal to f d square by L with respect to the star, right? And how it looks, for example, it would look somewhat like this. This is sun, suppose this is earth, and this is your star. Okay, let me draw it over here. This is your star, suppose like this. So this is and this. Okay, they're not perpendicular, of course, they might be at some angle. So this is the distance from sun, and this is the distance from star, right? Okay, so we are given the value of f for sun. What is it? It is 1.37. 1.37 into 10 to the power 3 into distance. What is the distance of sun and earth? Between sun and earth, it is 1.50, 10 to the power 11, right? Squared, divided by, what is L? Let me write it as Ls only, is equal to 5.4 into 10 to the power minus 16 into d square upon L, right? Okay, let me write it properly, upon L, right? Like this. So you get basically 1.37 into 10 to the power 3 into 2.25 into 10 to the power 22 divided by 5.4 into 10 to the power negative 16, right? Like this, into L by Ls. Well, what is L by Ls in this case? It is 10 to the power 4, right? Okay, so it is 10 to the power 4 is equal to the d square. So when you solve it, you get d is equal to approximately 2.4 into 10 to the power 22 meter. And if you express it in terms of light years, you're going to get 2.5 into 10 to the power 6 light years, right? And this is how you measure the distance of stars from Earth. See how simple it is. Of course, you need to know a bit of physics to, of course, to know these data, right? To observe this data, but it is not that much difficult. We use many techniques to find these data, okay? These flux intensity and all, okay? So no need to worry about that. That will be given you in the question if you are studying for the question related problems, okay? But in general, this is how the physicists use the idea to calculate distance. There are many other methods also. For shorter distance, we use the parallax method, and for greater distances, we use this method, and there are several other methods to find the distances, right? So I hope you enjoyed this video, and if you did, then please do like, subscribe my channel, and please support this video. Bye bye, take care.